Welcome to 10 CS. Today we are going to do the daily Leetcode problem for 11 September 2024. The problem is minimum bit flips to convert number. We are given a start number which is 10 in this example and a goal which is 7 in this example. We have to reach our goal by flipping the bits of that number, and they have defined what flipping a bit means. So in binary representation of x, we can flip it from 0 to 1 or 1 to 0. That means, let's say we have our 10 representation as 1 0 1 0. We can flip the 0th bit to 1. That will be counted as one flip. Similarly, we have to reach our goal in minimum number of bit flips. Now let's see how we are going to do this. So we have this number 10, which is represented in binary as 1 0 1 0, and we have our number 7, which is represented in binary as 1 1 1. All others numbers before this are zeros, so this will also be 0. Now if we closely see, for making 7 from this number, we definitely have to flip this 0 to 1. We don't need to change this. We need to flip this to 1 and 1 to 0. So clearly we can see that we need 3 flips, and that is our answer also. But how are we going to do it with our code? So we know the XOR operation, which states that let's say we have 0 0 or 0 1 1 0 and 1 1. This will be our XOR table. For this, the resultant output will be 0 if we have matching bits and 1 if we don't have matching bits. So we have to flip only those which are not matching, right? So we should use the XOR operation here. So when we will do 10 XOR 7, our output will be 1 0 1 1. So we clearly see the number of set bits, which is the number of flips we have made, is 3 here. But how are we going to find how many number of set bits do we have in the number? For this, we have Brian Kernighan's algorithm, the fancy name but a simple algorithm, which states that for any number, let's say n, we can find the first set bit by doing the AND of this number with the n minus 1th. So this number, if we'll see in decimal, is actually 13. So if we'll do XOR of 13 with 12, and similar, we will get the first set bit. Similarly, we can do this until we have reached 0. So let's try to do this. We have our 13, which is 1 1 0 1. We have to AND it with n minus 1, which is 12. So 12 will be 1 1 0 0. If we'll do AND of both of these numbers, we will get 0 0 1 1. Just for reference, I'll make the AND table here. So in AND, for those bits for which both of them are 1, we get 1. Rest of all, we get zeros. So now we have got this number, which is 11, which is 12, sorry. Yeah. Now we have to do the AND of this with n minus 1, which will be 11. 11 binary representation is 1 1 0 1. Now if we'll do AND of these two numbers, these are different, so 0 0 0 These are same, so it will be 1. Now this number is 8. Now we have to AND it with the number n minus 1, which is 7. So 7 binary representation we already saw here, which is 0 1 1 1. Now we'll do the AND of them. So as all of this is different, none of them is 1 1, so we'll get 0 0. Now how many steps did we used to reach our final goal? We used step 1, then 2, then 2. By step I mean how many times did we have to do AND. That was exactly same as the number of set bits in our XOR number. And that was our answer also. Now how will we write it in our code? Simple. We can use our resultant variable, which will store the XOR of this, and while our number, which is resultant, is not equal to 0, we can run the loop, and in that loop we can do our n and n minus 1 and increase our count variable. For reference, I have written the code here. We use the resultant variable, which will store the start XOR goal. We have our int count, which will be increased each time we do the AND operation. Until our resultant is 0, we will AND it with the next smallest number, which is resultant minus 1. And finally, we will have our answer, that is number of set bits in our count variable. Thank you for watching.